Hello and welcome to the Convert channel. In this session, you will learn fundamental of Flair network and the key rules and design consideration within the Flair system. You will also learn the pressure, including superimposed back pressure and build-up back pressure, and understanding how they affect the Flair system performance. As shown in the figure, a simplified Flair network consists of several key components, including the PSVs, tailpipes, subheaders, main headers, Flair knocker drum, and Flair stack. Understanding the function of each component will help you better understand Flair network design and operations. Well, let's start with PSV. You can see the vessel at the bottom right hand side of the figure. Its pressure reached the set pressure of the PSV. Once that happened, the PSV opened and released the excess fluid into the Flair network, and the vessel pressure reached to, say, for example, 8 bar. In this way, the PSV protects the vessel from potential damage. The pipe forms the Flair network that transports the relief fluid into the PSV to the Flair stack. The fluid is then safely burned at the Flair stack, converting hazardous components such as H2S and CO into less harmful components. Before discussing the Flair network design concept, limitation, and key considerations, we need to define total back pressure. Total back pressure is defined as sum of two components, superimposed back pressure and build-up back pressure. Understanding this pressure definition is essential as they play a major role in Flair network design. Build-up back pressure is the pressure generated at the PSV outlet once the valve opens and start discharging fluid into the Flair network. On the other hand, superimposed back pressure is the pressure presented at the PSV outlet before the valve opens due to the existing condition within the Flair system. Superimposed back pressure is of two types, constant and variable superimposed back pressure. Constant superimposed back pressure is mainly caused by the purge gas that continuously flows through the main Flair header. This purge gas preventing air from entering the Flair system, helping to avoid formation of explosive mixture inside the Flair network. Typically, the purge gas pressure or constant pressure back pressure is something between 0.2 to about 0.3 bar gauge. As we talked earlier, superimposed back pressure is of two types. Where does superimposed back pressure came from? Let's consider that due to the overpressure within PSV, A is activated and is in its relieving condition. As PSV A relieves fluid into the subheader, the pressure at the subheader that other PSV such as B, C, and D are experiencing is constantly changing with time due to the fluctuation in the relief condition of PSV A. And this is what we call variable superimposed back pressure. Why do we care about total back pressure? Because it helps us determine the Flair load and choose the appropriate PSV for the system. As a quick rule of thumb, conventional PSVs are typically limited to about 10% of total back pressure. Balanced balloons PSV can typically handle up to 50%. And pilot-operated PSV can handle even up to 100% of set pressure. Total back pressure is important not only for PSV selection but also because it affects the relief capacity of PSV. Let's understand this with a simple example. Imagine we have two identical valves. In the first case, the inlet pressure is 10 and the outlet pressure is 2 bar. The second case, the inlet pressure is 10 and the outlet pressure is 5 bar. Which valve will pass more fluid? Yeah, you're correct. The first one. Why? Because the pressure drop from 10 to 2 bar, the larger pressure drop results in higher flow rate. The same principle applies to PSVs. As total back pressure increase, the pressure difference across PSV decrease, which in turn reduce the amount of fluid that can be discharged. That's why total back pressure is important. But since we have not yet selected the PSV type and do not have any information about the relief load condition, we initially consider 2 bar gauge as the total back pressure and start sizing our PSV in filler analyzer. To have better understanding of the different pressure definitions such as superimposed back pressure and build-up back pressure, it is much easier to understand them in the figure. So let's start with the superimposed back pressure. As we talked about earlier, superimposed back pressure can be constant or variable. For constant back pressure, let's consider that refinery with 4 units A, B, C, D are operating on under normal condition. Constant back pressure is caused by the purge gas that continuously flows within the flare network. Now, for the variable back pressure, let's consider that the fire is happening in unit A. The pressure that other PSV in unit B, C, and D experience is called variable superimposed back pressure. But what about build-up back pressure? As we can see, this PSV in unit D is activated and is releasing pressure into the flare network. The pressure that PSV experience at its own outlet is called build-up back pressure. We have talked about all components within the flare network. What about tailpipe, subheader, and main header sizing criteria and design concept and consideration? To give you a general rule for the tailpipe should be sized so that pressure drop within it does not exceed 3% of set pressure. And for the subheader, the Mach number should be less than 0.7, and for the main header, the Mach number should be less than 0.5. So that's all for this session. I hope this made things clear and easier to understand. Thanks for staying with me, and I'll see you in the next part.